Welcome to math class. This video is intended to help you understand the notes on equations. Today we're just talking about, well, how to graph those solutions on a number line. So this is going to be a quick and easy lesson. Let's start out by just engaging our brains. Label the following number line by ones. So take a minute and do that. Press pause if you need to. It should just take you 30 seconds. Okay, so I wanted to notice a couple things, is that it starts in the negative direction and it goes over all the way from -5 to +5, and I did bring 0 out as just a little bit more noticeable just because it's easy to kind of judge things off of 0. I also wanted you to notice that I put arrows on the ends, and that's just to indicate that numbers continue counting. Like there is still 6, 7, 8, 9, 10 to the right, and there's -6, -7, and it goes on to the left. But we're specifically just looking at this one little spot. And this is something you learned in elementary school, but we are just going to be using the number line today to plot solutions, okay? So let's jump right in. First, I want to recall, like I always do, a few important terms. So what is an expression? Well, an expression represents a value. It's got a specific value. It can have operations in it. But it has no equal sign. So for example, if I said, let's say x plus 5, that is an expression, right? Because we know that it holds some kind of value. X plus 5, that's a value. And it has no equal sign. So how is that different from an equation? Well, remember that equation reminds us of the word equal. So it is got an equal sign. And what it does is it sets two values equal. So up there I've got x plus 5, and that's just an expression. But if I added on to that, x plus 5 equals 7, well now what I have, that is an equation. Because I'm saying that the expression x plus 5 is equal to the value 7. Okay? And inverse operations, those are those undo operations. So if I have addition, I can undo it using subtraction. And likewise, if I'm subtracting something, I can undo it by adding. It goes both ways. And if I multiply, I can undo that if I divide by the same thing. And it goes the other way. If I'm dividing by something, I can multiply by that same something to undo it. And a solution is a value for x, or a value for the variable that makes the statement true. So if I were looking for a solution to the example I have up there, what plus 5 equals 7? Well, I could say that x equals 2 because 2 plus 5 equals 7. So that would be my solution to the equation x plus 5 equals 7. X equals 2 would be my solution. So let's consider. A solution to a linear equation is the value that makes the statement true. We just reminded ourselves of that. So the solution on the number line is going to be represented as a point. So it's going to say, well, if x is 7, I know, or what was it on our last one? Let's say x is 2. So if x is 2, I know that the only thing that makes that true is where x is 2. So what would that look like? What would that look like? If I had a number line that said like -1, 0, 1, 2, I would put a point on 2 and say, well, that is my solution. But how do we find our solution? Let's review what we learned yesterday. What is the goal to solve an equation? Well, that's simply to get one copy of x alone on one side. On one side of the equal sign. And how are we going to do that? We're going to do that using inverse operations. So remember, the inverse of add is to subtract. Likewise, the inverse of subtraction is addition. And the inverse of multiply is to divide, right? And likewise, to undo division, you would multiply. So when we're doing math, when we are simplifying, we are going to use GEMS. We're going to start by looking at grouping symbols, then exponents, multiply and divide left to right, subtract and add left to right. But when we are solving, so to solve, we want to undo all that to get the variable alone. So we're going to undo everything using inverse operations going in backwards order. So we'll first look for, is there anything subtracted or added, multiplied or divided, and then we'll look for exponents and grouping symbols. So let's try this out the first time. We did this yesterday, so we're going to reinforce those skills that we used yesterday. We're going to use inverse operations to solve for x, and then it wants us to graph the solution on a number line. So initially we're going to look, and remember we're going to look at SMEG. So we're first going to see, is there anything subtracted or added to x? And indeed there is. Right now there's a plus 4. So the opposite or the inverse of plus 4 would be to minus 4. What I do to one side, I must do to the other. I'm going to carry down that equal sign because it's important that it stays balanced. On the left side, I have plus 4 minus 4. Well, 4 minus 4 is just 0. So I know I've got m plus 0 on the left side. And we know that because of the identity property, m plus 0 is the same thing as m. And on the right side, I've got a negative 12 and a negative 4. So negative 12, and I take away 4 more. Or I can think of the rule, same signs, add and keep. They're the same sign. So I'm going to keep the sign and just add those numbers together. And I get that m equals negative 16. If I want to test that, I can put negative 16 in for m. So negative 16, and I can say plus 4 equals negative 12. Well, negative 16, if I add 4 to that, it gives me negative 12. Is that equal to negative 12? It is, so I know that this is my solution. But the directions take it one more step. It says I need to graph that on a number line. So what I'm going to do is I'm going to go ahead and I'm going to find where negative 16 is on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I am just going to put a dot at negative 16. That's how I plotted it. And I do realize that on this number line, the numbering doesn't match up exactly perfect. So I did go back and I counted 16 spaces. But since negative 16 is my solution, I'm going to draw that dot right on negative 16. Okay, that's pretty much all you have to do. It's exactly what we did yesterday, only this time we're going to show that where x is a certain number, that can be represented on a number line. So your next step right now is to do the practice. There are 1, 2, 3, just 3 practice problems it looks like. And you're going to first solve by using inverse operations. You're going to solve for x, check it. And then when you're convinced you're right, you're going to put a dot on that number on the number line. You do not need to submit the practice to me, but you do need to do it. It's going to help you get used to this idea and understand that these numbers, these variables, they represent a specific value, and we can even prove it by putting it on a number line. Your next step after this is to click Next on your Canvas module when you're finished with the practice, and there is a game an online game that you can play with your table partner. You can each play, or you can play individually, that's okay too, but that's going to help you practice solving one-step equations. We need to be proficient at this. We need to be confident at this. So you're going to be doing that. You're going to be practicing it. Practice that for a little while. When you feel really good about it, you may work on your choice board. Remember, 20 points are due by Friday at 3 p.m. Good luck.